Today's topic is penetrating and non-penetrating orbits. Let us consider our atom. We know that at the center the nucleus is situated with positive charge on it, and around the atom electrons are moving in circular or elliptical paths. Let us consider these are the inner shells and these are completely filled shells. And these completely filled shells with electrons produce a shielding effect on the last electron moving in the outermost shell, and this electron is known as valence electron. Due to these electrons, the positive nucleus does not produce so much force so that it can attract the electron with a strong attractive force. These electrons produce a shielding effect, and let us consider this is the reason where the shielding effect or the electric effect of the electrons is considered. Now we will changing our atom structure into atomic core structure. This this field or this space is known as atomic core, where the influence of these electrons, that is the innermost electrons, are present. This atomic core has our nucleus as well as these completely filled shells, and this is our valence electron which is moving in an orbit. It depends whether it is moving in circular path or in an elliptical path. If the electron is moving in such an orbit that it is not penetrating the atomic core, then we define this orbit, that is the outermost orbit in which the valence electron is moving. If it is not penetrating in the atomic core, this orbit is known as non-penetrating orbit. And in case of non-penetrating orbit, K, that is our azimuthal quantum number, that is approximately equal to our principal quantum number. For non-penetrating orbit, this is the condition whether the orbit will penetrate or it will not penetrate. In the another case, let us consider this is our atomic core, that is the space having all these things, that is the shielding electrons or the shells or the subshells which are totally filled, and the nucleus. And let us consider this is our valence electron, and now it is moving in this orbit. Now you are seeing that this orbit is penetrating in the atomic core, and this is our valence electron, and this valence electron which is moving in this orbit is now coming under or intersecting the atomic core. Now this orbit is known as penetrating orbit. In case of penetrating orbit, K is very small as compared to our principal quantum number. As we know that n, that is our principal quantum number, it is the sum of the radial quantum number and the azimuthal quantum number, and the condition is that the azimuthal quantum number never be equal to 0. If n is very large as compared to n, it means there is a difference between the principal quantum number and azimuthal quantum number, and this difference is known as quantum defect. With the help of quantum defect, we can define whether our orbit is penetrating or not. In case of non-penetrating orbit, K is approximately equal to n. It means in case of non-penetrating orbit, the quantum defect value or the magnitude of quantum defect is very small as k approaches to n. But in case of penetrating orbit, that is where the valence electron orbit is such that it is intersecting or it is passing through the atomic core, azimuthal quantum number is very small as compared to the principal quantum number. In penetrating orbit, the quantum defect found out to be very large. Hence, if you have a question regard the quantum defect is very large. Hence, if you are having a question where you have to differentiate or where you have to define the penetrating and non-penetrating orbit, first you consider your atom and then change this atom into only two parts. One is your atomic core, which consists of nucleus, and another that is your electron, which is moving, that is your valence electron that is moving in the outermost shell. This is the outer orbit which will give the definition of penetrating orbit or non-penetrating orbit. If the orbit is non-penetrating, then you have to show it like that, that is the atomic core and the orbit are not intersecting at any point, or the orbit is not passing through your atomic core. And secondly, you can also define it with the help of principal quantum number and azimuthal quantum number. If azimuthal quantum number is very nearby to the principal quantum number, that is quantum defect is very small, then the orbit is non-penetrating type. On the other side, if the outermost orbit in which the valence electron is moving, it is passing through the atomic core, this orbit, outermost orbit, is known as penetrating orbit, and the condition of the penetrating orbit is the azimuthal quantum number is very small as compared to your principal quantum number. It means the quantum defect is very large in this case. And quantum defect, it is the difference between the principal quantum number and the azimuthal quantum number. We also know that the electron is not moving like that because the mass of the electron goes on changing. The mass change because the electron is moving in an elliptical path, and due to the path the electron comes out sometime very near to the nucleus and sometime it goes far away from the nucleus, and due to this change in the position of the electron corresponding to the nucleus, the velocity of the electron changes, and due to the change in the velocity, and if we consider the relativistic equation for the mass, that is m is equal to m naught 1 minus v square upon c square, where m naught is the rest mass of the electron, v is the velocity of the electron at different positions in the orbit, and c is the speed of light, then m mass, that is the mass of the moving electron, will change as the velocity of the electron change. And due to this change in velocity, the energy of the electrons does not remain constant, it remain changing, and the electron does not remains in a fixed path. It start to have a Rousset motion, which we already studied in our previous lecture, that is Sommerfeld atomic model. And due to this Rousset motion, the k and n relation changes. Hence, the penetrating orbit, which seems to be penetrating at first, no longer remains penetrating. It may be penetrating or non-penetrating as the time passes.